we are going to see how Sagemath can be used to find the limit of functions. You know, at a point, according to the definition of limit, we say that at a point the limit exists if the left hand side limit and the right hand side limit exists and both must be equal. Along with that, if the function value at the point of consideration equal to all the limits. So in Sagemath, we can find the left hand side limit and the right hand side limit separately. We can also find the limit of a given function. So three type of limits can be determined using Sagemath. There are actually three different ways of finding limits using Sagemath. Now the general syntax for finding limit using Sagemath is limit. You can use the limit function. The function used to obtain the limit is the limit function, limit limit. After writing limit, after typing limit, you can give the function the required function. You have to type the function, the given function, inside a bracket, and then put a comma. After that, you can specify the point at which the limit is required. That's x equal to a. You can see this is the syntax of the limit function. So limit in bracket f of x, comma the point at which the limit is required. But you know, if you want the left hand side limit at a point, or the left limit at a point, and the syntax, there is a slight change in the syntax. In the command, the command should be written as given here: limit of fx, comma x equal to a. Then the direction dir is the abbreviation used for direction, either from the left hand, from left direction or from the right direction. So direction equal to minus must be given inside the quotation mark. So direction equals equal symbol, then put the quotation and you can include minus. Then you have to close the bracket. But on the other hand, if you want the right limit, then you can modify. You can replace the minus part by plus. Minus should be replaced by plus to obtain the right limit. And now we are going to see some examples to evaluate the limit, which are given here to evaluate the limit of given functions. See, this is the first question or first example. Evaluate. Here it is asked to evaluate the limit of the function 2x square plus x plus 4 divided by, which is divided by the quantity x plus 1. The limit must be determined as x tends to 1. So here both the direction must be considered. Now this limit exists only if the left limit equal to right limit, and that equal to the function value at the point x equal to 1. But you know, there exists a single function to obtain the since there exists a single function, even though there exists a single function to obtain that limit, it is very easy to obtain the limit using Sagemath. But the first question or the first example, we are going to give it in a detailed way, because we will consider we have to consider a set of x values which fall in the neighborhood of or which come very close to the given point. Given point is x equal to 1 in this problem, x equal to 1, where you are trying to find the limit, and near that point x equal to 1, we have to consider a set of x values, and but this will be equally done in the case of considering both direction, I mean the left hand side and the right hand side. So we take some values, some x values on the left hand side and also on the right hand side, and we have to evaluate. After that, we evaluate the function value at those points, and then we will we can see the values of or the variations in the function values obtained at those points, to see and to get an to get a clear idea about the limit of the function. Okay, that's the way we are going to solve this problem. But you know, there exists a easy way to obtain the limit of the function directly. Here what we are going to the thing I have explained, you can see here, these are the, you can see the commands that can be used to find the limit of the given function in Sagemath. See, this is the first line, the second line, third line, and the fourth line. The 4 lines of commands we are using. After that, when we apply that, when we take the output, when we give the command to get the output, you can see the output in a table. In the table, you can see the set of x values, and the first column contains a set of x values. The first value is 0.91, and then 0.92, 0.93. Here you can see a difference of x value. We are taking x value with intervals 0.01. Having intervals, having width, we are considering intervals of width 0.01, and the starting value, the starting x value is 0.91. and it will then terminate the x values that we are considering will end at the point 1. So these are the x values, and then corresponding function values are calculated by the Sagemath system, and it is then displayed in the second column of the table. And the values, you can check these values, and you can see that the values are approaching continuously, and these values are changing, and they are approaching the value. Finally the value is 3.5. so from this value, using this value obtained from using this table, by analyzing the values in the available in the table, you can see that the limit of the function at the point 1 is 3.5. Okay, and this is but how this table is obtained, you can see. For obtaining the table, these are the 3 steps which are given in the first part of the solution. So this is the solution here. The solution starts here. In the first part of the solution, you can see the first we want to analyze this the steps of the program, or the steps of the program in detail. See, the first step is a definition step, in which we define, you can see the function def is used, def, and that stands for definition of a function. That's the abbreviation for definition, but it's a keyword. Def keyword says the Sagemath system that we are going to define a function having the name f of x. F of x is the function name, and then you put this the colon, fx then colon, and that is the standard format. You cannot change this format. So df, and after that fx is a name, so that name you can change. If you want, you can change it to gx, or if you want or to other notation you can use, some hx or kx, anything you can use there, and because it's a name selected by the programmer. But after that you can see return, and that's a keyword. That part you cannot change. You cannot change that part. Return, return, and after return you can see the function used. Function is return. The function 2x square. 2x square is return 2 star x. So 2x. So that is 2 into x. 2 into x square, which is written here in the form 2 star, using the operators, using the binary operations, star and cap. For exponentiation we use cap, and for multiplication we use star operations and star symbol. These symbols are used for that specific purposes. And then 2 into x cap to plus, then this x is then return, then plus again 4, and the whole thing is then put in a bracket. After that you use the forward slash to say that we are dividing this quantity by the denominator part, that is x plus 1, so that can also be enclosed in a bracket. So entire thing, the whole function is thus written here, and that function is therefore used after return. That means that the function fx is equal to this quantity which is given, this expression which is given here, but it will return the value of when this or the meaning of the entire statement is that give the value or return the value of this expression after executing it, after calculating its value. When an argument is given, argument means the value for x, when a value for x is given to that function. After that, so this is the explanation about the first line, and then coming to the second line, we define a step. A step is a variable actually. A step, it's a variable. So step stands for the interval difference, the difference of the intervals that we are going to use. That is the interval that we are going to use to define different values of, or to get different values of x, adjacent values of x. So this step size will be is decided using using this function. Using this command. The step is equal to, step is the variable, step equal to, then float is a keyword. So since it's a keyword, you can see it in a different color, in blue color actually you can see it. So float stands for the type of the number or the category of the number we are going to use after that. So 1 divided by 100 is the number. It will be a decimal number. In other words, it's a real number. So in order to treat this number as a real number or a number having decimal place, we use the command float. Instead, if we were using some number which is an integer, there must be a change in that part according to that nature of the number. So see here, the since the number used in this case is it's a real number, so we use that command float. In the second case also you can see the keyword float is used because that number is also an integer, a real number having decimal places. Then initial, you can see here the initial is used. It's also a variable, initial, and initial stands for the initial value of the number. That means initial value of x. We are starting with a given value of x, and that given value is 9 by 100. That means 9 by 10. That means 0.9. So So we take the value, we consider the x value from 0.9 onwards by keeping the interval or the difference between adjacent x values as 0.01. See, which is given here, and that difference is given in the second line, and in the third line we are giving the starting value for x. So we use the name we use the word initial and equal to the floating point number 9 by 10, that is 0.9. After that, the most important thing, that is the step or the command which can generate the table. Actually, the table along with the x values, we are going to generate the table which contains all the x values and the corresponding function values. So that can be done using this kind of by writing this kind of this type of step, in which you can see that command, this is the table is used. Actually, the table stands for this table we are going to create, and this table in this table you can see okay, in that table you can see the two things are mainly given in that table. This is the first part, and this is the second part. Okay, then you can see some brackets. After that you can see for I in, and then a range is specified. You can see that also. So for I in, the range from 1 to 10. It says that here I stands for the for an integer number. For I in range, in this kind of command, if it is given this kind of command, then you know I stands for stands as an integer variable. Here I is an integer variable. It acts as an integer variable, and that variable then takes values from 1 to 10. So from this range it takes the value. See, for that okay, let's one by one consider the various values of I, and then see what happens or how we are going to get this by analyzing this. But before that, let's come to the main sections of this the statement, the last statement. See, in the table, after typing table, you can see this bracket, and that bracket is closed here, and then you can see a square bracket. In a square bracket, then that square bracket is closed here actually, and this you can see this square bracket which is open there. It is closed here. In that square bracket, you can see one more bracket is opened, and after that I star, see the statement I star means I into step plus initial is the quantity used or the expression used. I star step, I into step plus initial. What does it mean? You know, step is defined here. Step is defined as 1 by 100, and actually that has value 0.01. So the value for value of the step, value of the or the quantity which is stored at the step is equal to 0.01. So 0.01. In short, 0.01. And what is the initial value? Initial value is 0.9. Okay, the initial value is 0.9, and the step value is value stored at our step is equal to 0.01. So when this command is executed, when this command is executed, the step will be multiplied by the value I, or I into step can give you the step quantity multiplied by the quantity I. Step is equal to 0.01, and then 0.01 plus 0.01 plus 0.01 yes, 0.01 into what is the value of I, and that is the main important thing now we have to consider. We want to know the value, the starting value of I, and for that you have to refer this part. I can take, I is a number, I is an integer that can take values from this a list. It's actually a list of number, and from this list it can take the first value of this list is 1. So assuming that I equal to 1, then we can calculate this value. So 1 into 0.01 plus initial value is equal to 0.9. Then what you are going to get? 0.9 plus 0.01, that is 9.1. Thus when I is equal to 1, you are going to get 0.91 here, and that is the quantity which is available here. And then corresponding to that value, after putting a comma, you are then evaluating, you are asking the system to Sagemath system to find the function value. So for that, when f is written, that means you are calling the function. The function f is defined here. That function is 2x square plus x plus 4 divided by x plus 1. So immediately, if as the symbol or as the letter f is read by the system, it immediately calls that function, in that and it gives the value which is given inside the bracket. That value is given as an argument inside the bracket, and that value will be given to that function. It will be applied to that function. So that value is, but you know that value is equal to 0.91. We have calculated it. 0.91 is the starting value, is the initial value. So initial value of x, actually it is like f of x. You know, the function is function text for f of x. So x is equal to, here you can see this quantity is equal to x. The quantity inside the bracket, the expression inside the bracket is x, but value, what is the value of x? Currently the value of x is equal to 0.91. so immediately the system will evaluate f of 0.91, f of this quantity, f of 0.91, and that will be stored in the system, and it will then immediately be written, and that way, because this command, this table command, it tells the system to display that content in the form of a table. So it will display the calculated function value. Then what does the system do then? After calculating this, since I is to be considered from, since I has to take the values, all the integer values from ranging from 1 up to 10. So it has to repeat the same calculation, has to be repeated by the system. About 10 number of times it has to repeat. So I will then increase to the next integer value 2. Hence immediately after typing this, I immediately becomes 2. I increases to 2, and then again it comes to this point. First it comes to the the system comes to the Sagemath system comes to the first position, and here but the value of I is equal to 2. Now the value of I is equal to 2. So the step will be multiplied by value. The value of step will be multiplied by 2, and then that will be added to the initial value. Hence we get the number x equal to the number which is equal to x, that is 0.92. We get that value 0.92 corresponding to I equal to 2 in the second step. Okay, then it goes to the second part. The system then control of the system goes to the second part. It then evaluates the function value at the point 0.92, and that can after that both quantities will be displayed, and after that what happens, the value of I is then again further increased to the next value, that's 3. So I goes to, or I becomes 3 now. Thus we have considered I equal to 1 and I equal to 2, and now we are going to consider I equal to 3. When I equal to, after increasing I to 3, then the control comes to this comes to the first part of the command, and then that value is evaluated. what is the value that you are going to get? Now we are going to we will get 0.93, the value, a new value of x. 0.93 is obtained. After that, control jumps to this statement, and it is then evaluated. That value is evaluated. I mean, f of 0.93 will be evaluated, and that value, you can see it is displayed here. So in a similar way, it goes to, after that, after displaying it, it will the control then goes to next I value, that is 4, I equal to 4, and then it evaluates. When I equal to 4, this quantity is evaluated and it is displayed, and a corresponding function value is displayed after that. On the right side of that x value, the function value is displayed. So in this way, the same thing, you can see, same thing, by same thing we mean the calculation of the first part and the second part of this expression will be repeated 10 number of times, starting from I equal to 1 and finally up to I equal to 10. It repeats, and you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and these 10 items you can see. This is the way we obtain all these 10 items, and finally all the values are then displayed in the form of a table. So this is the explanation on the working of the system. The working of the system when this kind of statements are given to the system. Okay. Further, the same thing can be calculated, and this is actually calculated from the left hand side. This is calculated. For calculating from the left hand side, and that will be clear after. After looking at the picture, the picture of the given function, the figure of the given function, and that's also needed for getting more understanding of the situation. It's because we are going to here this explanation, the explanation that we have completed here is for calculating, for obtaining the function values at different points which lay on the left hand side of the point x equal to 1. In a similar way, we can find the function values of some points, function values of almost 10 points which lay just out on the right hand side of similarly on the right hand side we consider, which are very close to the point x equal to 1, and which lay on the right hand side of the point x equal to 1 will also be considered. That you can see here, the right from the calculations from the right you can see. But similar kind of statements can be given, but there are some differences also. Some slight changes are there when we compare it with the calculations used or the steps used for left hand side calculation. In the case of the right hand side calculation, there are some changes. So this changes, there are changes at two places, and these changes are applied here, are given here to get to the or to consider. We have to consider the points on the right side, or to get to the points on the right side of the fixed point x equal to 1. Actually, we are giving that changes. You can compare the set of commands here. See, the first command is same. The function definition, that part is same in both cases, but the second command, step float 1 by 1 divided by 100, you can see there is a change. There we write minus 1 by 100 instead of plus 1 by 100, and it's because where we start from a point which is at a distance of 1 unit away from away from the fixed point x equal to 1, and from there we are step by step we are reducing the value. So after first we consider a point which lies at a fixed distance from the point x equal to 1, and then at that total distance, the entire distance from these two considered points, by the considered points means the fixed point at which we want to evaluate the limit, and the point which we are starting at the starting point. That from that starting point you have to consider a set of points. Here actually the number of points is 10 number of divisions or 10 number of points we are considering, and these points are spaced at equal distances actually, and for obtaining these equal distances, and also we are reducing the value to say that, to say the system that we are reducing the value actually x equal to 1, and then we will consider a point much higher than that value x equal to 1. At the point x equal to 1 we want the limit, but as a starting point we consider a higher value of x, and from there we have to reduce the values step by step, and for that we are using this minus sign. But in this case, we have taken a lower value. In order to calculate the lower limit, in order to get an idea of the lower limit, we have taken a starting value or the starting x point. We have taken a starting x value which is much lower than the actual value, where we are trying to where we wanted to find the limit. X equal to 1 is the point where we wanted to find the limit, and much below that point we are considering a point. That point is 0.91. Or actually it is 0.9, the starting point 0.9, and from there we are step by step we are adding 0.01 step by step, about 10 number of times. 10 times we are adding step by step the value 0.01. We are adding the value, and that you can see here we are adding that value, same quantity, step by step. But in this case, we are considering a higher value, that's 1.09 or 1.1 actually we are taking the starting value, and from there we are reducing the value step by step. We are reducing the value. In order to get this reduction of this value, we use minus of 1 divided by 100, minus 1 by 100 inside that float command. And after that, in the initial value is actually 11 by 10. Initial value is set as 11 float 11 by 10. That means 1.1. So the starting point or the initial value or the starting point from where the calculation of the function at different intervals, at points of intervals, at limit points of the intervals are starting at this point. 11 by 10 means 1.1. From 1.1 we then reduce the value. In the first step we reduce the value by minus of 0.01, and then we calculate the function value at that point. Then again we apply the reduction in the value of x is then further be reduced by a quantity minus 0.01, and then to get to the point 1.08, and there we calculate the function value. Then again we find the next lower value is 1.07. Then corresponding function value is calculated and displayed. Likewise it is done up to we reach the point. Up to the point we require that is x equal to 1. And then when we reach the point x equal to 1, you can see that the function value obtained is 3.5. And also when the function values are examined or when they are compared, you can see these function values are gradually decreasing step by step. These values are decreasing, and finally it is tending to the point 3.5. Hence from these two function values, the set of function values, you can conclude that the limit of the given function at the point x equal to 1 is 3.5. But for that, let's come back to the remaining part of the steps of the commands that we want to use, and that is the last part of the command. You can see that's actually same, the table, and inside then after table you can use the bracket properly. After that the same expressions are used as commands. The first expression, second expression, there is no change. You can compare it with this, no change you can see. And after that, then for I in range, because the number of steps in this case also is limited to 10, so we use the starting value 1 and then double dot, then we write 10. Okay, these are the actually Python statements actually, and because this program is, or the Sagemath system is working on the Python programming language. So these are Python programming statements. So if you know more about the Python, or to understand more about these statements, you must learn more about the Python commands. But actually that Python commands, or the details of Python commands, are not in the in the main matter of our discussion. So we are not going to much details. For those interested can refer the Python standard study materials. Okay, and then again compare. So we can in order to get an idea about that main differences of both calculations, you can see the first two statements are same, and but the first statements are same in both cases, and but the second and third statements are slightly different, and that difference, you may note that difference here, plus 1 by 100 is used in the first case, but here in the second case it is minus 1 by 100 used. But in the in the first case, the initial value is 9 by 10, or actually it is 0.01, sorry, 0.9. It's 0.9, but in the second case it's 1.1. I mean the initial value is taken above the point x equal to 1 in this case, and in the first case we are taking it just below the point x equal to 1. After that, the fourth statement is the same in both cases. Okay, and then when we implement this the 4 steps in Sagemath system, you can get this table. Okay, now we are going to see the demonstration. We are going to demonstrate the program in Sagemath system. Now, to get a clear idea about the hands-on, to get direct experience, to gain direct experience. Okay, this is the Jupyter notebook, which is opened in Sagemath system. See the Jupyter, it's the Jupyter notebook opened in Sagemath system. You can see I have applied the commands. I have typed all the 4 commands in the input in the input window in Sagemath, in the Jupyter notebook, which is open there in Sagemath, and there you can see I have typed all those things, and then when it is applied, or when it is implemented, when the commands are implemented in the system, we have obtained this output. You can see that is very similar to the output which is given in that manual. Okay, so we are going to for demonstration purpose, I am going to copy it again, because that will help us to save time just by copying it, and again pasting it into, by copying and pasting that commands into another input in a new input cell. And you can go through the statements. See definition, df f of x, definition of fx. How do we define that? Then and after this colon, return in bracket 2 into x cap x square plus x plus 4 divided by x plus 1. Then step equal to float in bracket 1 by 100 and initial value initial equals float float of 9 by 10, 9 over 10, and then the fourth statement table in ordinary bracket, then square bracket, again ordinary bracket, I star step plus initial comma f of function value function of I star of the same quantity, I star step plus initial, and bracket again, and for I in the range of 1 up to I belong to the list 1 to 10 here, but in only integer values are considered in that list. Okay, and then yeah, we want to take the output. So for that you use control and enter together and wait for the input the output to come. It will take the time to calculate. Okay, you can see that the output is now displayed there. Yeah, we have got that output. Okay, then and these are the values. You can see from point x values 0.091 to 1 at equal intervals are displayed, and then corresponding function values are calculated. Okay, next we copied again, and for obtaining that right yeah, this is for left hand value, left limit. These are the value changes, the function value changes happening on the left part of the point x equal to 1, and to obtain the value changes in the value on the right side, right part of the point x equal to 1, as we have explained, you can make slight changes in the command. Same set of commands can be used, but the change with slight changes, that there you have to, in the second statement you have to put minus. So I have applied that change in the second statement, and in the third statement that 9 must be replaced by 11. Yeah, to get to the number which is much higher than the point x equal to 1, but the fourth statement yeah, remains the same. Okay, and then after making those changes, so what did I do here? I copied the same statement to a new input window, to a new input cell. I have copied it, and after that I made the required changes. Now I am going to take the output. Okay, much easily we got, without yeah, taking much time, we got immediately, we have obtained that the value, function values in the table. So these are the values, but you can see here the x values are reducing step by step. The values are reducing step by step from the starting value 1.1, and finally it ends at the point 1, and there we got the value 3.5. Okay, and that's the demonstration on the problem that the example that we have discussed yeah, so far. Then we are now yeah, we are going to see this kind of lengthy calculation can be avoided, and you can immediately obtain, very quickly you can obtain the limit of the function using the limit command. Actually, there is a command which is called the limit command. See, now we are going to demonstrate the use of limit command. See, this is the limit command. The function, the same function is used here. You can see, let's analyze that before we apply that command. Let's analyze term by term, or the letter by letter, this the command statement. See, the limit command is the main part, and after that you can use a bracket, and inside that bracket, this bracket actually closes here. So the limit, so you can say that this is the bracket you coming along with that limit command. So limit, and then a bracket must be there. So limit bracket, so the end bracket must also be there, the closing bracket must be there. Inside that bracket, you can see, inside this bracket you can see there are two parts, two sections or two expressions you can see, and these two expressions are separated by a comma. So this is the first part of that expression, and that part is actually the function value, the function expression. Function is 2x square plus x plus 4 divided by x plus 1. That is the function part, and then we put a comma, and after that you can see here x equal to 1 is used. Why do we write that x equal to 1? It's because we actually want the limit at the point x equal to 1. In order to tell the system that this is the point where we actually want the limit, we use x equal to 1. That command x equal to 1 is used. So when we apply this in that Sagemath, when we execute this command in the Sagemath, you are going to see what result we are going to get. Okay, let's come back to in Sagemath, we in Jupyter Notebook, see, I'm going to type that after that I take the output. See, we have that output 7 by 2. What's it? 7 by 2 is 3.5. See, directly we are obtaining the value of the limit at the point x equal to 1. At this point x equal to 1, we are easily getting the value of the limit 3.5 or 7.2. It's displaying in the fraction form actually. The output is displayed and the number is displayed in the fraction form, 7 by 2. You can see. Okay. Now we are going to see another example. See this example 2.2.2 and evaluate. Here it is asked to evaluate the limit of this function 2x square plus x minus 1 divided by x plus 1 at the point x equal to 1. See, at the point x equal to 1, it's asked, you are asked to find the and you can see a change in the upper part, in the numerator part of the function. When we compare it to the function used in the previous example, there is a change in this function. So you have to type it as a new function. We will use it. We will type it as a new function. So see, how can you write that command? The command to obtain the limit. The command can be obtained. The limit can be obtained by typing a limit, 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 and then. So I shall demonstrate that by letter by letter typing it in that in the co-calcs. In the system, in the Jupyter Notebook, because that will I think that will be more useful for the listeners, because all the time copying it and then pasting will it will lead to some confusion in the understanding of the viewers. So not avoid that, at some point I have to use that direct way of typing. So I am going to type limit. So that command is typed. Then okay, then I put when I put one bracket, or it automatically it puts the other bracket, the closing bracket also. It's an advantage from our side. When we look at this from our side, it's an advantage for us, because it reduces the chance of making errors by mistake. You may you may not put the closing bracket due to tension or some other due to some other reason. You may forget to put a closing bracket when you put an opening bracket. That kind of errors can be avoided, since the system by itself it adds that closing bracket. So after that, one more bracket you have to put. So when because I am going to type that numerator part of the function, so I am going to type one more bracket. Then that bracket is also closed automatically. It is closed. And after that, which function we want to type? This is the function 2x square plus x minus 1, and that function can be type written 2x square plus x plus x minus 1. See this highlighted portion? 2x square. Okay, 2 star. You can type 2 star, then x, then cap, x cap, 2 star x cap, then 2. So now 2x square is now okay. Then plus or minus. Check it again. Plus x, then minus 1, plus x and minus 1. Okay, and that's the expression that's the complete numerator expression. So you have to then come outside the bracket, that inner bracket that stands for the inner bracket which now stands for the numerator expression, and after that you have to divide. So the numerator must be divided, and you can put the forward slash after, and again which quantity comes, it's x plus 1. X plus 1 is the denominator, so put another bracket, open another bracket, then it is automatically closed also, and there you can put x plus 1. Okay, now the function is now complete. Next you have to put a comma, and then you have to specify the point where we want actually the limit. So refer again that question. X equal to 1 is the point where we require the limit, so x equals 1 you can put. Now the function is completely written instead of copying and pasting, but it wastes time. So I am now going to take the very easily we obtain the answer, the value of the limit. When we take the output, we get the value of the limit. It's 1. I can see that here also 1 is obtained. Now coming to that next question, evaluate a limit of x square plus x square minus 1 divided by x minus 1. But here this is not the ordinary limit, it is the left hand side limit, because as x tends to 1 minus is asked to find. Here limit of, you have to find the limit of this expression, limit of the fraction as x tends to minus. So here we consider x as the variation of x from the left hand side up to the point x equal to 1. So for that, you have to make a slight change in that command for obtaining that left hand side limit. For obtaining left hand side limit, see, this is the command used. The first part of the mainly the command is same, but there is a slight change we want to make inside that command, inside the last part of the command. See, the point at which we want to obtain the limit is x equal to 1 is the point where we want to find the limit, but the limit must be on the left hand side, it must be calculated from the left hand side, or we want the left hand side limit. For that you must type, after completing that main that statement after completing main statement for obtaining the limit, you have to you have to make an addition after x equal to, after specifying the point at which we require the limit, you have to put one more comma. You have to use a comma, and then you have to specify the direction dir, and put this command dir equal to in quotation mark. When you put a single quotation, then the system automatically adds the second the closing quotation. when you put the single quotation, it then it automatically adds that closing quotation. So don't worry about the closing of the quotation. If you try to close the quotation, then there is a chance of error, because you may get 2 quotation marks there, so that should be avoided. Inside the quotation, you can type minus. So you type minus inside the quotation. So then after implementing this command in the system, then you will get to the limit. So I am going to copy and paste it, but when I copy and paste, that an error will be there in that quotation mark part, because that may not come properly when by copying and pasting command. Therefore I am going to type that quotation part. I am directly I am going to type it, direction equals, see, direction equals, then I put the quotation. No, that single quotation I want to write. Then direction must be minus. Okay, is this minus? MINUS, no error must be there while typing. MINUS, minus must be correctly MINU, no, it's MINUS, minus MINUS. Okay, let's take the output. The output is 2, limit. So the left limit is 2 for that expression. For the same expression, suppose we want to find the right limit, you have to consider this problem. See, in this problem you have to you can write the same statement for computation, but with the change that the direction part, minus, plus must be used instead of minus. So for obtaining the other limit, you have to replace minus by plus. So see, then I am going to cut and paste the expression, same expression, because same expression is needed, but with the change that minus is replaced by plus. Okay, then take the output. Okay, plus limit is also 2. Minus limit and plus limit both are 2, and then you may check whether it is same, or whether the function value exists at that point in addition to this, to confirm that the limit of the function exists at that point. Okay, that we are not very much interested in that mathematical part, because we want to increase our understanding how to use the Sagemath system, or how to write commands to find answers to some problems in calculus. See, in calculus, this finding limit is an important area. Okay, and how can we use the Sagemath system to solve problems related to finding limit of functions? So that's the topic of our discussion. The much mathematics is not a point of our attention here, but we need all the basic principles and all basic ideas behind behind the calculations of limit. Actually need to understand or to follow the discussion or the commands that are written here. Okay, then if you want to find the, see, another problem, another example is given here. X plus 1 by x plus 1 over x plus 3 is the function given here to find the limit at the point, you have to find the left hand side limit at this of the given function at the point x equal to 3. Here again we want to find the limit of the function x plus 3 over x x plus 1 over x plus 3, x plus 1 over x plus 3 at the point x equal to 3, but the limit is left hand side limit actually we require. Sorry, it's a mistake. Because minus is used before 3, so the number, the point at which we require the limit is x equal to minus 3, and it is not the left hand side limit. We want the actual limit at the point. The original limit we want at the point x equal to minus 3, not at the point x equal to 3. But if it were at if it were the left hand side limit at the point minus 3, then it must be minus 3. After that, one minus sign must be given. Okay, so you can use use this command, limit x plus 1 divided by x plus 3 comma x equals minus 3, and you can implement that. You can run it. Okay, now the another question. Next question is, you have to show that fx equal to 2 into cos 1 by x does not have a limit. It does not have a limiting value as x approaches 0. See, we want to show this as x approaches 0 or as x tends to 0. As x tends to 0, the function fx equal to 2 into cos 1 by x. The function fx equals 2 into cos 1 by x does not have a limit. We want to show that. Yeah. For that, we are going to use the first method that we discussed in the case of the first problem. The method that we discussed in the at the opening part of the of this video. In the first problem, we have considered a set of values, x values, which are very close to, which are nearing the point at which we want to take the limit actually. And at those points we have determined the function values. After that, then analyzing that the nature of the variations of the function values, we decided the limit. So that was the procedure that we applied in the first problem. The same procedure can be applied in this problem also. Okay, for that we define the function fx equal to, we define fx equal to 2. Yeah. This is another way of defining the function fx equal to 2 into cos 1 by x, and after that, then initial value is float 1 by 10, and step is float minus 1 by 100. It's exactly as in the previous case, but here we consider the variation of phi from 1 up to 8 only. Integer variation of phi is considered from 1 up to 8. Okay, then that function and these commands we are going to use these commands to obtain the values. Okay. Okay. You can see that the same is done one early. So I have done that. See, I am going to copy it from here. I have checked whether it is working. Already I have checked. See, I am going to copy that. See, instead of fx, instead of fx we use hx. That function name is just changed. That's all. Some changes are there. Only that the change is made to keep the function. Already we have defined a function fx is there in the system. One function is already defined fx, and that function is you can see that function, the plot of that function also here, and that function fx was used in the first problem. So actually I don't want to change that function value. I want to keep that function. That's why I am going to use a new name for the function hx. So the new function is hx equal to 2 into 2 star. You can compare, and the other parts are same. Hx equal to here the name of the function is we just change the name of the function. H of x equal to 2 into cos 1 by x, and initial value it is float of 1 by 10, and the step value equal to float of minus 1 by 100. And then table, you can see the same all the same commands are used in table. Equals I star step plus initial comma h, but the change that the function value must, since the function is changed here, corresponding change must be made wherever that f is used. F is used here. So there, since this f is changed to h, you have to change all f to h. So there are two places f is used, so all those f's must be changed to h. So h of I star step plus initial, and then for I in range 1 to 8. Okay, and that's done, and after that we can take the output. Okay, now you can see that as it the function value, as we go through the function value, when we consider the point here, actually it tends to as it approaches 0, we are considering it approaches 0. So see, the starting value is 0.09, x starting value of x is 0.09, then 0.08 is taken, 0.07 is taken. At 0.09 we get 0.23, it's a positive quantity, but at 0.8 at 0.08 we get 1 point. It's a much higher value, 1.99, and when we take 0.07 we get again minus quantity. So but when it is 0.06 0.06 we get minus quantity, but as we go to 0.05 we get positive quantity. When 0.04 it's positive, then but again it changes to negative, and then it goes to positive. Thus we can see that as we approach the point x equal to 0 along the positive direction of the x-axis, or from on the right side of the x-axis, we get that function values are changing its sign alternately, or it is not continuously keeping on one side. That function value is changing from positive to negative, or then from negative to positive. So this is a dangerous sign that there does not exist any limit for the function at the point x equal to 0. But you can make this point more clear by plotting the figure, by plotting the graph of the given function. Graph of the given function is 2 into cos 1 by x. How can we plot the graph of the given function? We have explained it in an earlier video, but I would like to remind you about that. For that you can use a plot function, but that plot function, before using plot function, it must be assigned to some value. That plot must be assigned to some variable. So for that we can use g. The new variable g, a new variable g is defined, is taken, and then it is to this new variable, we are going to assign the value of the plot, plot, and after that function can be the function 2 into cos 1 by x. It's copied from there, and that value is then this is pasted. And now I am going to take the output in display, I want to display that output. For that, you cannot directly obtain that output. For that, you have to type a G again, and then you can enter. You can take the output. So G is assigned that plot, and then we type G to obtain the plot. So this is the plot of the function. See the plot of the function. From the plot of the function, it is clear that here we are considering the point 0,9. Starting point is 0,9. So the mid value, the point, the origin x equal to 0 is this point. This is the point x equal to 0, where that cursor moves. You can see x equals this points correspond to x equal to 0. So the starting point is point 0,9. So that's a point which lies on the right side here, somewhere here. That point 0,9 lies somewhere here. From that point we are moving step by step by reducing its value. By reducing the value of x, we are moving step by step up to the point x equal to 0. We are moving to the point x equal to 0, but you can see that in each step, the basic nature of that curve is basic nature of the function is that from the curve it is clear that so as we reduce our value from a higher value of x to a lower value of x, it so for some time it keeps in the positive at the positive direction of y-axis. Function value is taken along y-axis. So the function keeps positive for some time, and after that it crosses the y equal to 0. That is the x-axis. It crosses x-axis means y equal to 0, and then it goes to the negative side. Then further it reducing its value further, and after reaching a point, a particular value, then it starts increasing and it keeps increasing. Keeps on going, increasing that value, and then further reaching after reaching a certain value. So as it increases its value, it reaches a certain point, and then it starts reducing its value, and it comes to it reduces its value further to a point, a lowest point, and then from there it starts increasing its value. So that's this is the nature of this is the common nature of the basic nature of that function, and it can this nature is kept without any change as we change the function, as we change the value of x, as we move along the x-axis. You can see that this nature is continuing. The nature of the function is continuing. It is not losing this property. So that's why we get the function value at some points positive. After that it becomes negative, and keeping it negative at some points at some places, and then again it becomes positive, and then it goes to negative, and then becomes positive. Likewise, it keeps going on, oscillating. So and this is the nature of that function. What is the nature? It's the oscillating nature of the function value. Oscillating nature of the function value is the basic nature of that function. So due to this nature, the limit of the when we think about that function value, you can see that it does not continue without variation in a neighborhood of some particular number. The function value cannot continue in the neighborhood of some value, some number. As a result, we have to say that the limit of the function does not exist at the point x equal to 0. Thus we have an analysis. Thus we have the direct determination of the limit of the function. Using that approximation method. Actually, by using the method of approximation, we have tried to obtain the limit whether there exists. but actually here it does not exist. In this case we have realized that it does not exist in this case, but we have applied that for obtaining that, for deriving an idea about that, we have applied that method of direct analysis. That method is used, but by using a single step, applying a single step operation, you can obtain easily the limit if there exists. If we apply that, let's try that using that limit function. Whether you are going to get any value for this limit, you are going to check. You can verify that whether you are going to obtain. And also we have got a direct verification. We have got an opportunity to directly verify the nature of the function by using that plot command in Sagemath, and it's also another advantage of that system. See, then we are going to apply the limit command to obtain an idea about the limit of the function. Okay, I'm going to copy that function, and then okay, limit inside that. Okay, we use bracket, and then once again you have to use another bracket, and then the function can be copied. So I have copied that function, and then you put a comma, at which point we want to find the limit. X equal to 0 is the point where we actually require that limit. Thus we have now completed that command to, then the complete command to, we have completed the command to obtain the limit. Then you can take the we can take the output, and this output you can see here it is it's given as IND, that means indeterminate. You cannot find actually the limit, because the limit here does not exist. We can conclude that. So in the case of in the case of a limit that does not exist, you can see the output as indeterminate. It means that we cannot find that limit. We cannot determine that limit. Okay. Okay, you can see that figure. Now the figure size can be reduced. This is the normally obtained you can that figure, the previous figure is the normally obtained figure. You can see here, when that's obtained by giving that command, that plot command as you can see in the input cell, that command. But you can slightly modify that that command to obtain the output in various style. You can change the appearance of the output, so that also you can see what are the changes that can be possible, and that can be used here. You can resize the output actually. Output means the size of the picture can be changed. In our previous video earlier we have explained that by giving some range for x, you can specify the range for x, and also you can specify a range for y. In the specified range you can display that that picture, And also you can resize the picture using the fig size command. You can use the keyword fig FIGSIZD, fig size. So let's see that the changes that we are going to get when these are also included there. So for that I just copy and copy and paste it in that in the new part with comma. Then I have to put a comma. To that you can see x, and we are specifying a range of variation of x, a suitable range for x, and that is from -1/10 to 1/10 plus 1/10, and the figure size is also specified. Okay, after that we take the output G. You can see the resized in a new shape. You can see that figure. See, this is the figure, the same figure actually. The same figure is obtained here, but it's resized. Size is adjusted, and some range of the figure is also specified. So here you can see x value ranging from -1/10 to +1/10. Only that in that range, only in that specified range, you will see that figure. Okay, and you can further you can change the values. You can further change these values to obtain to modify that figure according to your choice and interest. Okay, and that's up to you. For that, the command, the changes that you can possibly make in that command, you can see that. Refer this command. So we are not going to discuss it more. Okay, next example. We are coming to the next example. Investigate the function limit of the function. Investigate the function fx equal to x by modulus of x as x tends to 0. So by investigating this question, what does it mean? It means you want to comment on the nature of the given function x divided by x over modulus of x at the point x equal to 0. So, or then in the neighborhood of the point, you have to consider the neighborhood of the point x equal to 0, and you have to comment on the nature of the function at that point. For that, we use this command. We want to plot the figure also. We will plot. So for that, for analyzing or for getting an idea about the nature of the function at that given point at x equal to 0, we are going to use these steps. Limit. First, we want to find the lower limit and upper limit. Of the lower limit means left hand side limit, and the right hand side limit of the function at the point x equal to 0. Okay. See, we write limit x divided by absolute value of modulus of x at the point x equal to 0. We want to find the limit at the point x equal to 0, and this is now direction. Direction is minus. For that a correction is needed because you just put bracket and then okay, then retype minus. Then take the output. Now we get to the lower limit, or the left hand side limit. Left hand side limit is -1. See, the same quantity or the same command is copied to obtain the right hand side limit. For that, this minus part is replaced by plus us, plus 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 is retyped there. Then you take the output, but you get here in this case we get the a different number, that's +1 as the limit. So the left limit of the given function, what's the function here? The function y is the given function is x by modulus of x. the given function is x divided by modulus of x. For this function, x by f of x equal to x by modulus of x. See here, without defining that function, we didn't try to define that function, a separate function. We directly give it in that you directly give it in that in the command, a limit command. That's also possible without defining a function. So function definition, first defining a function is the proper way, but without even without defining a function, you can directly use it in that in any command, and then you can use it as we require. And you can take the ordinary outputs. Okay. And thus we have obtained the lower limit and then upper limit. Now we are going to plot the function with figure size 3 in the range -3 to +3. X range of variation of range in which that function we want to display is x equal to -3 and x equal to +3. So okay, but you know, I would like to give it another name. Instead of g, you can see here g is used, but I want to change because already the function already g contains some figure. I don't want to delete that. So for that, for this reason, I will type I type k is equal to, not g. So you can I have defined a new variable k, and that variable is then allowed to store. It is then allowed to store the figure which is generated by that plot command. Okay, then take the output. By taking the output, for getting figure we need to wait some time. In all the case, why it's not coming? Okay, we have to wait. We'll come back to that that window, but you know, this is normally we are waiting for this figure there, but time is being taken by that system because it is much slow. Oh, that not yet come. Oh, sorry. One more. I forgot one thing because we want to type that k also, because we want to take that output. Actually, we want to take the output without typing that k. In the case of g, also we typed g, but in this case I forgot to use that. So see, it will easily come. Okay, but since k is storing that figure, we want to take the output of we want to take that figure as output. So you have to type k and then enter. Then you can see that this blue part is the graph. So for the function when we take the point x equal to 0. See, this is the point x equal to 0. At this point x equal to 0, the function on the left side, the function is negative. The function moves in this region, but the function on the right side of the point x equal to 0 is that lies on the upper side of the y-axis. Or that is positive. Here in this side it is positive, and on the left side of the point x equal to 0, the function value is negative. And so you can say that the limit, what about that limit? The left limit is -1 and the right limit is +1, as the calculation says. You can see here the left limit is calculated, it is -1, and the right limit is calculated equal to +1, but unfortunately the function is not continuous at it is not continuous also, but more actually we want to say about that existence of limit. Here the limit does not exist for that function at the point x equal to 0, because the left and right limits disagree at the point x equal to 0. That's the point that we actually wanted to explain. Next, limits involving. Next, we are coming to the problems where the limits are involving the trigonometric functions. Some trigonometric functions, if the expression or the function contains trigonometric functions, then also we can very easily find the limit. So for that, consider this example. Limit of sine 3x when it is divided by x as x tends to 0. So for that, you can write the command limit then in bracket in sine 3x divided by x comma at the point at which point at x equals 0. So I am going to copy this, and you can take that you can see that output very easily. Yeah, 3, you can see 3 is the answer obtained. Okay, if you want to plot that that also that curve also, you can, if you want to plot that curve, you can use the plot command. You can use this command, plot sine or plot of that function, then x equal to -1 plus 1. So I am not going to do that, because many plotting many plotting examples has been demonstrated here. So it will be a repetition. So, but you can note the command for that, for plotting that function. This is that command. Okay, next problem. Okay, we want to evaluate limit of tan t divided by t. Limit of tan t by not ordinary t, by modulus of t, or absolute value of t. Absolute value of t as t tends to 0. But the variable, the independent variable is given as t instead of x. Only that change is there. But you can, for convenience, you can again change it to x. So t can be replaced by x. But wherever you use once you use x instead of t, then you have to use the same variable everywhere in that, throughout that function definition. You have to use the same variable. See, that command is written, limit, to find that limit of tan x divided by absolute value of x, then x equals 0. Then direction, here it will give you the left hand side limit, and then direction is the direction plus is used, then you will get the right hand side limit. When direction minus is used, you will get the left hand side limit. So this is right hand side limit, you are going to get the left hand side limit here. And and then plot, you can plot that that curve also. You can plot that curve using this plot command. You can see that, you can try it, but if you want to limit that, if you want to limit the range of that output, range of the figure from the upper y value from the lower y value -10 to the upper y value +10, that means from -10 to here, this is the lower limit, -10 for y, and the upper limit for y is +10. So between these two limits, lower and upper limits, you can see that figure. And for the x values, the limits are -4. See, the lower limit for x is -4, and upper limit for x is +4. So from -4 to +4, and from -10 to +10 for y value, we get to that figure. Now, how can we obtain that limit? Can we apply the same function to obtain the limit at the point like pi and 2 pi? These are the points, some special where that special values occur. See, so for explaining that, see, let's consider this example. You have to find limit of 1 by cos x at the point x equal to as x tends to plus pi. You have to find the limit of 1 by cos x as x tends to plus pi. Okay, for that you can write that command, limit of 1 by cos x comma x equal to pi, and we are going to use that in the Sagemath. Okay, and then take the output. Yeah, -1 is obtained. So it's not a very big task actually. Very simple calculation, simple typing and simple procedure. So another okay, for the same sin x, for solving the second problem, for solving the second problem, you can write limit of 3 cap sin x comma x at which point, x at minus of pi by 2. So x at minus pi by 2 you have to write. So I am going to copy it and demonstrate. I am going to check it whether it is correct. It's giving the value 1 by 3 correct. So that that command is correct, no mistake there. And simultaneously you can take the limit value at a set of values at a set of points actually. For that then you can see that the use of that. Okay, and this is a special question. You can see how this question works when it is run, when it is implemented in Sagemath. How this, you can know, there is no specific value of x at which the limit is asked to determine. You can see a set of values for z, for the point, for the limit evaluation as are given. A set of values for the evaluation of limit are given, and that those values are c equal to 0, pi by 6, pi by 4, pi by 4, pi by 3, and pi by 2. And these are the values: 0, pi by 6, pi by 4, pi by 3, and pi by 2. So at these values, the function whose limits we want to evaluate is sin x minus sin c by sin c, sin x minus sin c divided by sin c, and okay, sin c by minus sin x minus sin c divided by sin c is the function. So one thing is clear, that you have to define that function properly. You have to define, you have to use that function. But the values, there are the values at which we want to find the limit are given as equal to c. How many such values are there? 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. There are 5 values given for c to evaluate the limit. So we want to evaluate the limit values at all of these points. This can be done, but normally how could we do that? Separately you have to find the values of the limit for c equal to 0, then c equal to pi by 6, and c equal to pi by 4, etc. For all values of c you have to consider. You can write the program, but you can simply write some program, some statements in 2 or 3 lines, and you can very easily implement this program, and that's shown here. So for that you have to define a list which contains different values of c. So first we are going to define a list which contains the values of c. The values of c are listed here. So we define c equal to 0, pi by 6, pi by 4, pi by 3, pi by 2. So this list is first defined. After that we write the loop statement, the statement that repeats how many times, that many times actually we want to consider the value of c for obtaining the limits. So that many repetitions of the calculation, the limit calculation must be there. So how many such values are here? 1, 2, 3, 4 and 5. There are 5 such values, so 5 times the calculation of limit must repeat. So for that you write for I in range 5. For I in range 5 it actually considers the values from 0. For I in range 5 it will then take values from integer values for from starting from 0 up to 4 it will consider. Then I can range in the among the integers 0, 1, 2, 3 and 4, not 5. But from 0 to 4 how many times it can repeat? 5 times it can repeat from 0 to 5 as we count it from 0. And when we reach 4 the counting will become then 5. So 5 times repetition is done, and therefore for I in range then colon putting colon you have to write limit of sin x minus sin ci. So this ci stands for the c0 and c1, c2, c3 and c4, and ci stands for different values of c which are present in the list starting from 0, from c0, c1, c2, c3 and c4, and these are the values. Let's try this in that let's proceed with this commands in the Sagemath system and see whether it works. Okay, and this is just by copying, pasting, so you have to directly type it because pi, for obtaining pi, okay, the mistake is that pi you cannot use that pi by 2. Actually you have to write pi, I think so. C is equal to, let's write c equal to, then square bracket, in square bracket what is the first number? 0. Okay, and 0 comma then pi by 6. Okay, pi by 6 pi by 6 and pi by 4 pi by 6 pi by 4 and pi by pi by 3 pi by 3 and pi by pi by 2. Okay, then for I in range 5, that we can copy. Okay, when tabbing is automatically it is given the tabbing and then limit. There is a chance of occurring some error because we are copying it directly from the okay, there is where is the command to display that, the output? Okay, okay, let's try this. Let's try to take the output. Yeah, an error is there. So by typing, since we type it, since we directly copy it, some error might have occurred, and that we have to check. Okay, and we have to check it because we have copied it from that system. Some symbols were there and there is a chance of misunderstanding that the meaning of that symbols by the system. That chance is there. We cannot avoid that chance. And also so anyway, we have to debug that the problem. We have to, okay, we will come back with that, but before closing to that, now another important thing, another thing is limit involving infinity. We are going to, before stopping this video, we want to discuss that also, and after that we will close this. Okay. See, you may be asked to find the limit of this kind of functions as extends to infinity. Now, limit, you have to see the problem. Limit of 3x minus 2 divided by root of x square plus 2 as extends to plus infinity, and limit of 3x minus 2 as extends to minus infinity of 3x minus 2 divided by root of x square plus 2. So this can be solved by using the point x equal to, we want the limit at the point x equal to infinity, but infinity can be written in words can be written infinity, not as a symbol. So because if you use symbol, it may not be understood by the system. It will not accept that symbol. So you have to type it in this way. Limit, and then the function limit, you have to find the limit of the function, and then comma x equal to infinity. So we are going to copy and paste it in the that is